Okay, when you start this, get everything to one side first, right? So I didn't exactly, but because this had a sine and a cosine in it, so you can just do that part first and then get it to one side. You cannot solve one equation with two variables. So your one identity that you have to remember is your Pythagorean's identity. So that way you can get your cosine in terms of your sine or vice versa. Or your tangent and your secant come from that. So substitute this in, and then I got everything to one side. It's probably easier this way. You're not dealing with the negative sign when you move it in the beginning. Remember, be careful when you distribute that one is a negative. So get everything to one side, and now you have a basic trinomial. If you have trouble seeing it, take out the word cosine. At this point, you should be able to factor this. This is not a tough one. Factors of 1 and 1. Then go for your sine. They're both positive. So what are factors of 2? Just 1 times 2, right? So you only have one way to put this. It doesn't really matter because you're both plus 1. So 2x, 1x, or 1x, 2x. And then replace this with your cosine. Now you can separate your two factors. Where is your cosine? And you only had to, all solutions, you had to solve all solutions. You had to figure out first where your cosine was negative. It's where your x is negative. So you've got a reference angle of 60. There's your pi over 3. So this is 2 pi over 3. This is 4 pi over 3. And remember the 2n pi for all solutions. It just keeps looping around your 2 pi, then 4 pi, then 6 pi. And you need to remember to say n is any integer. At least say it once somewhere there. This guy has a quadrant angle. There's no restrictions in these. Anywhere that my cosine is -1. So at the pi, and add this in there. And if you want to, like, loop it around and get the pattern of it, 1 pi, 3 pi, 5 pi, you'll see it go. So 2n pi. And n is any integer. Keep that in one section. You only have to say that n is any integer once. Questions? Can you do this? Talk to me where this is not happening. Aaron.
I don't get how you
None of these had the quadratic equation, so you were pretty good with this one. Now, this guy has a square in it. When you physically undo a square, you get a plus or minus. Remember, your tangent is y over x, 1 over 1. If the sides are the same, what's your reference angle? 45. So I've got a 45-degree angle. It goes in here 4 times. So my first guy is 4 pi over 4. Now, I only need to go across a half a circle to get to that other terminating side. So now I only have to say plus n pi. Then I find this guy, which is 3 pi over 4. If I go across 180 over here, don't I hit his terminating side? Plus n pi. I don't have to give all 4 plus 2n pi. It's not wrong, but this makes it a lot cleaner. And remember just to make sure you say n is any integer. Right, right. Tangent is always going to be n pi, Shelley, regardless if it has a square or not, because your tangents are this. Your positives are opposite each other. These are your positives. Your negatives are also opposite each other. So tangents are always going to be n pi because their period is pi. If you think about their graph, it takes them only 90 plus 90, 180, or pi to complete one period. It's not like a sine curve. So our tangent will always have that. The fact that this had all 4 was because of the plus or minus. Okay? Questions? Aaron? Where am I?
Humanities ninth period.
Humanities ninth period. Well, tell me what your problem is now. I'm sure there's somebody else that struggles with the same thing.
Oh, yeah, why you go?
All right? Now, you're in a nice situation, and all I want are the solutions from 0 to 4 pi. But you have to start with your all solutions. So the first thing we do is we figure out where I am. I'm all quadrants again. The first thing you want to do is all solutions. Even though I only asked from 0 to 4 pi, which is your 2 pi plus one more, circle around. So if you wanted to, you can even work these in degrees if you struggle with your radians, but I would like you to see them in radians. So we know that this is y over x. This guy is a 60-degree reference angle. So this is pi over 3. This is 2 pi over 3. This is 4 pi over 3. This is 5 pi over 3. Now, if you're only going from 0 to 4 pi, if you wanted to, can't you just do it this way? 1 pi over 3, 2 pi over 3, 3 pi over 3, 4, 5, 6, 7, 8, 9, 10, 11. Can't you do it that way in a cycle? You could absolutely do that if you wanted to. However, if you start this way, it's easier. This one sends me across here, plus n pi. This one sends me across here, plus n pi. Now, remember how we set this up. If you want to go to 4 pi, let's convert this to fourths. How many fourths is 4 pi? What do I get on the top? 16 pi. So when I get to 16, I know I reached my 4 pi. I stop. So let's start with this one. I'm going to add pi. Let's convert this to thirds. So how many thirds is this? What's my numerator? 3 pi. So every time I have to keep adding a 3, that's a 1. So when I add 3 to this, what do I get? 4 pi. Add 3 again. Add 3 again. Oh, thirds. Thirds, thank you. Thirds. Sorry about that. Thank you, Alex. Alex, thank you. So now, if I added another 3, wouldn't I be over my limit? So I stop right there. This was thirds, because we had a 60-degree. Now, do the same thing for the next guy. You have 2 sets of angles to go through. If you had 4 and 2 pi, how many angles are you going to get if you go another 2 pi? 4 and 2 pi, 4 in the next 2 pi, how many altogether? 8. So I need to get a total of 8 angles. Aaron, you with me?
Yeah.
Okay, so add 3 pi to this. What do you get? 5 pi. Add another 3 pi. Add another 3 pi. Now if I add another 3 pi, I'm over my limit. So here's your angles from 0 to 4 pi.
So whenever it says 0 on the 4 pi, the 4 pi is what?
The 4 pi means we just go around one more time. We go from 0 to 2 pi. From 0 to 2 pi, you have all these angles. Right? You have all these angles. If you're going to go around again, you're going to get 4 more. But, of course, it's the same as I went another 2 pi, so they have to be larger than these. I have to add 2 pi to. You can technically add 2 pi to each of these if that's what you wanted to do. So that's like adding 6 pi. So there's your 7 pi. There's that guy. Add 6. There's your 8. There's that guy. Add 6. There's your 10. Add 6. There's your 11. You could do that if you wanted to. Just go around one more time. Let me put this in degrees. let's work in degrees a minute. Here's my 60, right? If I add, so from here I have 60, 120, 240, and 300. If I'm going to go another 360, after this one, what's that second angle going to be? If I add another 360 to this, what will this be? Add 360 to 60. 420. If I took 420 and I converted this into radians, that would be my 6 pi, or would be my, what did we say that was? 7 pi over 3. This is going to go in here and reduce. It will reduce to 7 pi over 3. I can put 60 into both of these. So 7 over 3. That reduces to your 7 pi over 3, which was this guy. If I add 360 to this guy, I'm now at 480. Convert this. Convert that one back. Do you see what I'm saying? If you have a hard time seeing it in radians, convert it to degrees. 360, the next guy around, I'm from 360 to 720. So my second set of degrees has to be higher than 360, but less than 720. I think it's harder in degrees than in radians. But if you have trouble, convert it. Look at it in degrees. You got to go 360 and another 360. So that gives you from 360 to 720, or from 2 pi to 4 pi. Yeah? No? Where am I losing you? All right, let's take a look at this. We're going to find all solutions and then solutions between 0 and 4 pi. You know what? Let me get out of this guy a second. And let's go here and do this right from scratch. Okay, what's the first thing I need to do?
Cosine x equals cosine x equals -1.
Okay, 2x squared plus 3x plus 1. Am I all in the same variable? So, we're going to factor this guy. Now, if you hate looking at it like this, then look at it like Trey just gave it to me, with the x's. Cosine is x. Oops, look what I did. I know, I mixed these up. I'm saying put x's in there, and I totally took the thing out. Put an x for cosine. Make it 2x squared plus 3x plus 1. This is a trinomial. This gets factored into 2 binomials. What are factors of 1? Go for the easy guy. 1 times 1. Factors of 1. When I multiply this and I get a positive, and I add this up and I get a positive, what are my signs in here? Plus and plus. So now, my factors of 2 are just 1 times 2. Does it matter where I put them if they're both identical? So 2x, 1x. Now, replace the x with the word cosine. You've got 2 factors. Solve. So I say each one is equal to 0. I subtract 1, I divide by 2. Is that okay if I take a shortcut? So the cosine of x is equal to -1/2. Now, what? Yeah, let's work with this guy. Is everybody okay with the cosine? Yes.
I thought when you like the things, you separated it to like cosine. Isn't it like what multiplies and then like adds it?
What multiplies to? Well, it's if you do a times c. But if you're just doing something that's this simple, that because this guy has a prime, right? It's not a prime, but it only has one set of factors. And this only has, that's your prime, it only has one set. It's going to fit in. The hard part is when you do this. Well, whatever this happens to be, like plus 7. Then you do a times c, and you do what multiplies and what adds. We don't, I told you, you're not even going to get that difficult because What are your triangle sides? 1, 2, and radical 3, radical 2. They have to be small. So they're pretty much going to be small in here. Now, let's take this guy. Cosine is the x or the y? Yes. So, where's my x negative? Right here. So I get two triangles. So, 1, 2. This guy's a radical 3. What's my reference angle? So, in radians, what is 60? It goes in 3 times, right? So pi over 3 is my reference angle. So this is 3 pi over 3. So what's this guy when I stop short of the 3? 2 pi over 3. What's this guy when I go right past the 3? 1 more than 3. 4 pi over 3. Now, that's my solutions between 0 and 2 pi. I want all possible solutions. So, if I come here to this one, to give me another one that I terminate there, don't I have to add 2 pi? And keep adding another 2 pi and another 2 pi? So there's my 2n pi. Same with this guy. I have to come back around to this. Give me a full circle again. Plus 2n pi, where n is any integer.
So that's why we add 2 and 5, because you're coming around again.
Because we're going to keep coming around and around and around and around. And if we're only going halfway, Aaron, what are we going to add?
You want to add 5.
Pi. And pi. Ooh, we have a breakthrough. Thank you. Okay, now, this is all solutions. Now we need to go from 0 to 4 pi. So how many am I going to end up with? If there's 2 in 2 pi, how many all together in 4 pi?
8.
Just these 2. There's 2 in 2 pi. 4. 4. Who said 8? I said 8. I'm not 8. 4 Okay. All right. So now, how am I going to find that other angle? There's 2 pi over 3, and there's 4 pi over 3. I need to find one more set of angles. How do I find it?
Go around again.
So I'm going to add 2 pi though. 2 pi over 1, convert that to thirds.
So 6 pi over 3.
So 6 pi. So add 6 pi to the top. What do you get?
12.
Add 6 pi to this guy. What do you get?
Oh, no, yeah. 10 pi over 3.
Now, it comes full circle back around, guys. It comes full circle back around. Watch, if this is 6 pi over 3, this guy was 7 pi over 3, this guy was 8 pi over 3. Ooh, we got him. This guy was 9, this guy was 10. We got him. We got the both of them. Double this. Add double this guy. Put the 2 pi back in here. Okay, because this is 6 pi. Watch. This would be 9 pi. What's one less? Oh, 8 pi. What's one more? Oh, 10 pi over 3. We're only going back around one more time. Now, let's take this guy. Cosine of x plus 1 equals 0. Cosine is equal to -1. Oh, when my sine and my cosine is a 1 or a 0, where am I located? At the quadrants. So cosine is my x or my y? So is it going to be here or here? To the left. So therefore, pi. All solutions just come back around. Plus 2n pi. Those all solutions, I will always come back to that point. If I only want it between 0 and 4 pi, watch how easy this is. There's pi, there's 2 pi. If I come back around, what's this guy? 3 pi. So my 4 from 0 to 4 pi gives me 6 solutions. Just work it out logically. I'm recording this now.
You're recording this right now?
Yeah.
Talking about what?
Hi. Shout out to
This one. binomial. How do I write this without the word cotangent in here? X squared plus 2x plus 1 equals 0. So how do I factor this? XX 1, 1 plus plus. Oh, aren't they the same factor? So now I'm going to take out the x and put in cotangent. Do I have to do this both times? No, because they're both the same. So my cotangent of x is equal to -1. Cotangent is x over y. So what reference angle do I have? 45, when your sides are the same. Now, what quadrant is cotangent negative in? That's positive. 2, and 4. It's got to be across from each other. They got to be across from each other, your tangents. So now, here's my 45-degree angle. This is 4 pi over 4. This is 8 pi over 4. So, what's this angle short of 4?
2.
What's this angle short of this side?
6.
7 pi over 4. Now, if I want all solutions, guys, if I want all solutions, I only need this one because, Aaron, what am I going to say? I take this, what am I going to add to it?
Go at pi.
And pi. If I want to go through another step, just go like this. Make this be 12. Make this be 16. And figure this out. 1 short is 11. 1 short is 15. Yeah.